What is differentiation? Differentiation is just a limit. This limit have 4 expressions. This is the first one. This is the second one. This is the third one. This is the fourth one. And then what we did last time, okay, this is a theorem. Fx differentiable implies Fx continuous. But the opposite is not true. We have this example. This guy continuous but not differentiable. This guy continuous and differentiable. Similar question can be x over absolute x. What about x power 3 and then absolute value? This kind of thing. And then this 4 bullet point is what you learn in high school. If you have a u and a v, so u, v are differentiable, we assume the limit exists. Then this prime or a symbol means differentiation, just lazy notation, okay? U plus v differentiation is just u differentiation plus v differentiation. This is called sum rule. How do you prove that? You prove this limit is what you want, right? What you want is this. This is in the H notation. Again, you can always write the proof in the other 3 notation. So u differentiation, so this is the differentiation of u, this is the differentiation of v. And then I can take the limit out. Why I can do this equal? Why I can move from here to here? Or why can I move back? Because limit can be distributed if what? If both of the thing inside have a limit. Remember from the limit, if an converts to a, bn converts to b, then an plus bn, I can have the limit converts to a plus b. So this is the reason why I can have this equal sign. Equal sign is like if and only if in the set. So you can go from the left to the right, and you can also go from the right to left. Here it's like go from bottom to the up and go from top to bottom. Then what is this? This is just the definition of this guy, right? So u plus v is my what? It's my fx. The definition in the h notation is fx plus h. My f now is u plus v. So everything inside u and v I need to plus h. And then minus fx. My f here is u plus v. So u plus v. So this is the definition. Then what is this equal sign doing? It's just a rearrangement. Okay, this have u, this have u, this have h, so I group them like this. This have v, this have v, this have h, so I group them like this. This is how you prove, or how do you understand why u plus v prime is like this. And then similarly, you also have this. If you have a function u, multiply constant, take differentiation, you can ignore the c. And then what is this? This is called product rule. If you have u, v multiply together, then you can have u prime v plus u v prime. You differentiate one of them at a time, and then you sum all the possible way you can differentiate. This is quotient rule. It's just a special case of product rule. You can then just say this is a function u, and the v function is a 1 over something function. And then you just apply this, and then you simplify the math, it will give you this. In other words, you only have 3. This one is just a side product of the first one. Of course, you also need to make sure vx is not 0. V cannot be 0 is because we cannot divide by 0. V itself, can it be 0? Of course it can be 0. If v is a 0 function, that means it's a constant function. Everywhere is 0. Is it differentiable? Yeah, it is. So this is true, right? There's nothing saying that v cannot be 0. The reason why v cannot be 0 is just because we are doing division. Okay? So these are the proof, and some of them are very, very long. You don't need to read all of them. It's just understanding, okay? And these are what? These are the H version. And then you can do the A version. And then you can do the Q version. Or you can do the epsilon delta, which is even more long. And then the practice of this kind of proof is, let's say this one. dxn and xn minus 1. Okay, I have proof 1 and proof 2. Let me do proof 2. Suppose I want to differentiate x to power n. N is integer, okay? Then I can write it as x times xn minus 1, right? Then what? Because of product rule, this is u and this is v. So this equal sign is product rule. Here's important. At this moment, I'm assuming I don't know this. So you cannot tell me, oh, this is just n xn minus 2. Or you can tell me this is 1. No. I'm assuming I don't know this. So I need to prove this. So what is this? This is just this, right? By definition, this bracket. X minus x disappear. And then h divided by h, 1. Whole thing. Just 1. So this term become this term. There's a 1 here. Then here's the question. What about this guy? Okay, this guy is this guy. Now I'm going to repeat this step again. Because n is an integer, I can always do this. So now this part becomes this bracket. And then this bracket thing, I'm going to use this equal sign. Because now I am just doing the same thing from here to here, which I just do some simple algebra. This is true for any n. I can say this is a mathematical induction. Then I keep doing this. And this is why you see there's a dot dot dot. I keep doing this until I reach integer 1, which is exactly this bracketed term. Then I will finish because I cannot proceed. That's the smallest one. It's called the base case. Then in the end what? I will just keep summing all the term, and it turns out it's n xn minus 1. So what? This is a way you prove this simple formula by mathematical induction. This is method 2. You can also prove it by method 1. Method 1 is harder because method 1 requires you to know this a to the power n minus b to the power n. You can take out one negative part, and then all the things inside are positive. Then what? I now do the same thing here. an in the h notation, I will have an minus bn. I now do this thing, a minus b. This is a minus b. This big bracket is exactly this big bracket. Okay, then what? This guy, x minus x cancel out, h stay there. This h divided by this h gone. I left with this super big bracket. So this is my super big bracket. I can just put the h to 0 here. So then I get this, and then these are a bunch of what? Xn minus 1. This is x minus n minus 1. This is xn minus 2, but I have an x, so it becomes xn minus 1. And the same. Very important. This is not general proof. You cannot say, oh, n is a half, then I get this. These proofs are only true for integer. Then you may wonder, let's say I put n is pi. Pi is irrational. How do you prove this? You need to go to the epsilon delta proof. This is a simple one, okay? That's it. This 4 rule must remember. Remember this 4. And then what? Also remember this one. And also these. These are exactly formula in calculus.